Welcome everyone to the weekend meeting here in Klagenfurt. And thank you, hosts, for inviting us here. It looks amazing. Looking forward to the meeting. First, I would like to hand over to the host if you have some information.
Okay. Thank you, Cheryl, and good morning also from my side. I'm very happy to have the WCAG meeting here in Klagenfurt, and specifically thank you, Adi, for organizing here. It's good to see so many familiar faces here. I guess some more people will come, and hopefully also the people joining online have a good experience with the setup that we have created here. But I will not. I don't want to stop you from working. I think Hadi has a bit of a logistic information, and of course, if you have any questions or comments, please feel free to approach me, and also feel free to approach Hadi in case you have any questions. If you want to know more about the place and about the stuff going on here, just let me know, and I'm happy to tell you more about some backgrounds, but also I think during some of the social events, we will have some time to chat about all it is.
Thank you very much. I'm also very happy to have you here, both in person and also for online participants. So I will keep it very short. So I will just have some slides about the meeting and then hand over to Cheryl to continue the meeting. So just the most important information is that all the information that you need, you can have access through this website. I also printed, and you have also on the tables there, but also I send an email to every WCAGers. So as you know, then you are here, the meeting will place here in a hybrid mode. So it will be streamed through the Zoom link that I already shared with all of you. But how to reach here, you know that you are here. So, but check the website if you are online and you want to participate later on. So also we share the Zoom link. If you have any problems, also please feel free to contact me. And if you want to share your slides, you can easily connect to the Zoom and share your slides there. So it would be very easy. Just make sure that you will mute your own laptop during the presentation, because all of the audience can be reached by this meeting call. So we will have 2 coffee breaks, as you saw maybe in the schedule, but feel free to take coffee or something during the sessions as well. So it is behind you there. It's easily approachable. So we will have lunch breaks, I think, from 12:45 to 13:45, if I'm not wrong, but it will depend on the presentation. It might be a bit different, but we will have around 1 hour, I think, lunch break. But we will share where we want to go through the WhatsApp group. So also you have my contact if you are not in the WCAG social group. So please ask me to add you in the group. So we will have also official dinner, which will be on Wednesday evening, and it would be exactly in front of the university, the restaurant. So I recommend not to go there during the lunch break because we will have the dinner, but it's also okay if you want to try it before the official dinner. So how to reach to the venue? So if you didn't figure out, so we have taxi, and recently Uber started to work in Klagenfurt, but you always have bus connection to the university, and also you can reach here by bike. So the name of the app, if you want to book the tickets online for the bus, is this app. You can book daily and weekly tickets here. And for the bike, you can use the Nextbike app. And we have a bike station exactly in front of the university.
A question with the bus, is it possible to pay in any other way?
You can also pay by cash. So it is 2.5 euros. So if you want to pay by cash, but the daily price is 5 euros. So if you want to also have a daily ticket online. So you will have the QR code and you can show the bus, but cash is also possible.
You can pay directly at the bus.
Yes.
Okay.
Yeah.
Then for the lunch break, I put some recommendation on the website. So these are the options that it will take around 3 to 5 minutes by walking to reach there. So we recommend that we all go to one of these because we will have enough time to have lunch and come back and continue in time the meeting. So for evenings, so we will share that where we want to go together. But one also option is that we can go to the football public viewing in the city center. This is also one option, but also please check website for more options. Sightseeing, so I shared some information in the website. Please feel free to use this information in the website if you want to have some good experience in Klagenfurt. And communication, you can always use email, but also I shared my WhatsApp, this is on the table. So if you need something, please feel free to reach me, and thank you very much. If you have any questions, I will be happy to answer. Seems everything clear. Okay.
Crystal clear. Thank you, Hadi. Very nice.
So please.
Okay, as the normal tradition, we will introduce ourselves as the first. So just tell who you are, where you're from, and briefly what you're doing, and then if you have any kind of position role in Weekway, that would be nice to know for those who haven't been here before. So we take the room first, and if there are anyone online, they can introduce themselves. I see that we are not. I would expect a few more people arriving, so maybe we will have those introducing themselves after the coffee break or something like that, or when there are more people online as well. So my name is Kjell Brandström. I work for RISE, Research Institute of Sweden, and I'm one of the co-chairs for Weekway, and I'm also vice chair for 5G KPI. So maybe you can go this way.
I'm the technician from the university.
Okay. That's okay.
Yeah, hello. So I'm Christian Timmerer. I'm here professor for multimedia systems, and research is on video streaming and quality of experience. And here I'm hosting now with Hadi.
Hello everyone, I'm François Blouin from Meta. I work both in California and Calgary, Canada. My focus area is on testing quality of experience. So we run labs across Meta to test mostly video and audio quality of our products.
Good morning, my name is Jesus Gutierrez. I'm assistant professor at the Universidad Politécnica de Madrid. I'm one of the co-chairs of IMG, the University University.
Maybe we can move up on that side and then move.
That's maybe so. Hi, my name is Michał Eleszczuk, and I'm from the AGH University of Krakow. I'm the associate professor at the Institute of Telecommunications, and I'm the co-chair of the Krakowian group here at Weekway.
Hello everyone, my name is Mohammad Hassanpour. I'm the first year PhD student here studying in Klagenfurt University. My research topic is about content-level video coding and video compositions.
Good morning, everyone. I'm Sofan Reddy. I'm studying computer science master here at Klagenfurt University. I'm doing my internship about video processing. Awesome.
Hello everyone, my name is Yuan Yuan, joined PhD in Klagenfurt Universities of Klagenfurt. My research topic is security and knowledge of JPEG.
Hello everyone, my name is Kamal Qureshi. I'm in the Athena lab in the Klagenfurt University. I'm doing my PhD work. I'm the first year of PhD work here, and I'm working in video coding and compression.
Hello everyone, I'm Mingwei. I'm the first year PhD student in the Athena lab in the University of Klagenfurt. My research topic is about video streaming and video learning.
So I'm Pablo Perez from Nokia, from the Extended Reality Lab in Madrid, in Spain. Also co-chairing the 5G KPI group here in Vicox with Shell, and helping Jesus with IMG as well.
Good morning, my name is Narciso Garcia. I am professor at the Universidad Politécnica de Madrid, the Technical University of Madrid. and I am interested in working in immersive video and communications, especially 5G communication.
Hello, my name is Sumi Hamel. I'm a second year PhD student at the University of Cambridge under this version of Rockwell. And I'm working on video quality assessment and varying sustainable information.
Hello, I'm Rafa Maciuk. I am a professor at the University of Cambridge. I'm not associated with VQuip so far, but I've been working for a long time on visual difference predictors and quality assessment for higher architecture.
Good morning, I'm Enrico Matala from Politecnico of Torino, Politecnico University in Torino, in Italy. I'm the professor there. I'm working on coding and communication, multimedia coding and communication systems, and I'm co-chair of the JEDAC group in VQuip.
So good morning again. My name is Sadi Amirpour. So I'm affiliated with the University of Klagenfurt. I'm working on video streaming, video coding, and quality of experience.
Okay, thank you. Do we have anyone? Do we have people online?
Few online, so maybe one person.
Should I go first?
Yes, please.
Hi, everybody. This is Yannis Katsavounidis from Meta, part of the video infrastructure group. My interest is on video compression, video quality, know most of the people there. And I'm also a co-chair of SAM and Norm.
Miriam?
Hi everyone, I'm Myriam Moutas from INSAREN in France. I'm one of the co-chair of quality assessment for health application working group, and my interest is on quality assessment for medical contents in general.
Yeah.
Thank you.
You and Alex?
Hi, my name is Alex Racker. I'm participating from TU Ilmenau in Germany, and yeah, probably most of you know me also, I think. Working on video and audio quality in my team, and video streaming, and since recently also quite intensively on social XR. And I am affiliating between Q14 in study group 12 of ITU and VQuip. So I'm one of the, together with Chul-Hee Lee, I'm one of the two IRG AVQA co-chairs.
Thank you. Then we can move to Chul-Hee Lee. Yeah. Oh, you're muted, I think.
Hello, my name is Charlie Lee. I'm working at the Yonsei University. Currently, I'm a co-chair with Alex, IRG AVQA. Also, I'm a rapporteur of question 19 of study group 12. Thank you.
We have more people online. I saw Silvio flashing. Fine.
Yes, hello, I'm Silvio Borger from Rode & Schwarz. I'm co-chair of AVHD, and my main interests are in objective quality assessment, actually currently through many ITU projects and VQuip.
Thank you. Yes, Marta?
Hello, morning. I'm working in Nokia and the Student Reality Lab, and my line of research is quality experience in Thank
You were breaking up a little bit there, so I think we got it, perhaps. Who else do we have online? Anyone else online that has not introduced?
We have Nabajit, and I see also Avrayoti.
Please.
Hi everyone, I'm Nabajit. I work for the Future Technology Group at Sony Interactive Entertainment, which is also known as PlayStation. I work mostly on the cloud gaming application there. I am the co-chair of the emerging technology group here and the CGI group also. Thank you.
Okay, thank you. Maybe we do a few more after the coffee break if there are more people joining. Then I saw Maria was joining us, so maybe you can.
Sorry for being late. Maria Martini, professor at Communication Systems University, London. A number of working groups here and sharing
And that's joined now.
I'm from the alternative.
Okay. Welcome. Okay, let's continue with the brief updates from the working groups. Since there are new people joining, it's very good if you give a background to the project, so everyone understands what you're working on, what you have been doing lately, and what you plan to do or present during this week, so we know what's coming up. So I will see, maybe I will take it from the list of the week week homepage. So WeekWeg is organized by working groups, and they are listed on the homepage, weekweg.org. And the first one is AVHD, so on the list. So go to AVHD, make a update.
Even though I'm not technically a co-chair, but I would like to just present to the group. AVHD is one of the more traditional and oldest projects, and it studies the general subjective and objective methods, both quality metrics, to analyze the quality for video only and also audiovisual quality. Based on the website, the conference calls are done on an ad hoc basis, and two activities are listed. The first one is, from what I understand, a dormant activity, QoE metrics for live video streaming applications. It was triggered perhaps a year and a half ago, but as far as I know, there hasn't been much progress lately. The idea always being, how can we define the holistic experience of a live session, and what exactly makes it different, say, from a VOD, where in particular latency makes a key role. The questions for that specific sub-project, live QoE, was supposed to be sent to Sahid and Rohit, but I don't believe any of the two are available. So let's say I'm standing up for anyone who might have interest in doing work on live QoE. And the second part, again listed, is the Advanced Subjective Methods, AVHD sub-project, which essentially tries to do some new experimental design validation, aiming primarily longer video sequences. And the work was spearheaded by Lucien, Ludovic, and Margaret in a paper that has already been published in 2019. And anyone interested can contact directly Lucien or Margaret. Back to you, Sal.
Yeah, thank you, Yanis. So, anyone else wants to share anything about AVHD. Otherwise, we will move to human factors for visual experiences.
Yes, so this is actually a group that originated from the idea of managing the police standardization. So in the HFD group, realizing the police standardization on human factors for visual experiences, in particular for immersive systems. So the focus until now has been on light field, for instance, light field quality assessment. So I was also involved in the standardization of the belief on the quality assessment of light field imaging. Recently, we have seen that there is interest in this topic, really well in the meetings in preparation of this meeting. So we may decide to use this name and this topic as umbrella for other activities. And in particular, in this meeting, there have been three presentations for this.
So, sorry, I maybe missed, but do you have anything program for the meeting this week, or?
There are three presentations on the topic. I can introduce the topic, but at the moment, the activity on light field is somehow on standby since we completed the first standard, the quality assessment of light field imaging. And we will definitely create an update, but it's probably still early because we recently completed the first one. But of course, if there is interest in this group to the update of the standard, this is very welcome. So we may have a short, maybe before the three presentations, we may have a short discussion. Before the three presentations.
Okay, yeah, thank you. Maybe I could. So, if you haven't seen it, most of our information is shared via this homepage. So, let's move on to the quality assessment for health applications.
Yes, I'm here. So we are our group mainly focus on the quality assessment and visual attention for medical contents and health applications. To date, we proposed mainly two studies, two publications about quality assessment of medical contents. One was a paper about subjective studies, and the other one was mainly focused on objective quality assessment, let's say. And now we are trying to work on how proposing a draft for to describe methods for assessing the quality of video and images. So something about subjective tests. So if you are interested, please join us. All information are on the web page. For this session, we have only one presentation, which is scheduled tomorrow morning. It's about a data set. I think it's all for me.
You maybe we could also yes. I should have shown this earlier.
Thank you, Shell.
So here is the schedule for the week, and the QAH session will be tomorrow morning. We are now in the overview week projects part of the meeting, and also for the previous groups, the AVHD has a session tomorrow afternoon and Wednesday morning, and then HFVE has a session tomorrow morning. So okay, let's go back to so we then have the SAM group.
And that would be me again.
Yes, please.
So yes, some statistical analysis methods is a group that is focusing exactly on two major axes. One is how to improve by the analysis methods and understanding of subjective experiments, and also improve the statistical analysis of objective media quality predictors and models. We are structured with chair. The group has Lucian Janowski is our chair, and we have three vice chairs, Zi Li, myself, and Patrick Leclerc. Our conference calls take place every 4 weeks. On Monday, typically 5 p.m. Central European time. We're working on a number of items, and the ones that have more or less been completed. The first one is the maximum likelihood estimation, MLE, of subject parameters, and this landed in ITUT P910. The December 2023 version incorporated our contribution. There is a package, a corresponding software package called Surreal. It's an open source GitHub analysis package that basically implements what is in the standard and more. There is a container, a JSON container called SuJSON that can be used to encapsulate in a standardized way subjective experiment data that then can be fed into Surreal. And also there is work done on the generalized score distribution. So as a quick status update and what's happening in this meeting, we have 6 presentations, if I counted correctly, but we are also working actively, and this has been the core focus for the past 6 months, on what we say the future of SAM. So we are looking to new challenges and also understand what is the role of the group after we have completed the items I just mentioned. There is ongoing discussion in our once every 4 weeks call, and we hope to get more feedback in this meeting. Among the things that have been proposed, and I would like to throw them to this group just to, as an appetizer, we want to see and study objective metric, both quality and significance. And there are a couple of proposals. We like to call it Margaret's and Lucas's proposals from work that has already been published, that tries essentially to associate the goodness of an objective metric either as in comparison to how a corpus of subjects would be able to evaluate, or how would the metric agree or disagree based on significant and non-significant pairs of stimuli. We are also looking to how to properly obtain BD rate calculations for comparing, for example, video codecs or any other HRC against objective scores. How do you, for example, aggregate different sequences, and how do you do proper statistical evaluation? We want to find the best possible ways and propose them for combining existing new data sets. And again, we're open to more ideas. Unless there are any questions, back to you, Sal.
Thank you, Yanis. So then AVHD have also the objective part. I think Yanis mentioned part of that. So maybe there are no more updates there. So in that case, we move to the CGI group.
Yeah, I think someone is not here, so I don't know why my camera is a bit. Maybe
Little bit blurry.
yeah, it's a bit dirty, I guess. Apologies for that. I will quickly share a couple of slides. Is that okay?
Let's go ahead.
Yeah. Can you see it now?
Yes.
Okay. Hi everyone. Again, this is Nabajit and together with someone, we share the group called Computer Generated Imagery, which was created, I think, 6 years back in March 2018, weekly meeting in Madrid. Again, the main focus of the group is to analyze and evaluate quality of computer generated content. So the web page is linked here if you want to have a look into the details. The work has so far been limited again to gaming content mostly. We are looking for more collaborative ideas. So the activities in this work led to completion of 3 ITUT work items in study group 12. These are mentioned here. So we have DG1022, P.809 and G.1072. They were completed a few years back. And there are still 3 ongoing items. I think one of them, which is very active, is the P.BBQCG currently, which aims to build a parametric bitstream-based quality assessment model for targeting cloud gaming services. So the current activities is again, we are continuing work on mostly towards targeting towards gaming. So there are data sets being developed currently. One, for example, is under the work item of ITUT-P.BBQCG, where there are data sets being developed up to considering sequences up to 4K and 120 frame per second. Other activities that we are currently working on is to develop no reference metrics and models, and also looking towards machine learning or deep learning based, so the Gen AI based gaming content quality enhancement. So how that's being affected and how to model those. Recent activities in this direction again was one of that we created an UGC VQA challenge at AI for streaming workshop in CVPR 2024 this year. You can check the link here for more details. The winning model will be presented here. It's called COVER, a comprehensive video quality evaluator. And like I said, the most active item under this group would be the ITUT P.BBQCG work item, which is still ongoing, and there has been a model proposed, which is an adaptation of P.1204.3 ITUT standard from TU Ilmenau. I'm not sure if there is any presentation on that, but yeah. So that's all. If you are interested in learning more about the group or its activities or have any comments, these are our contact emails for Saman and myself. And I think that's it. You want to go with the other one now or later?
The other one, the emerging.
Yeah,
Yeah,
it is.
yeah. Yeah, go ahead. I mean.
Okay, so I will give a brief overview of the emerging technologies group. So this is a very one of the newest group here at VQuick called the Emerging Technologies Group. So the main goal here is to look into technologies that are newer technologies, mostly into AI-based technologies and how they are going to impact the way that we assess video quality, right? So that's the main objective of this group. So what we do as part of this group is we typically invite researchers from different domains to bridge the gap also between, say, machine learning and deep learning community and the quality assessment community. And we invite them to give talks here as part of this group. So mostly we want to explore areas of machine learning based or deep learning based, AI based, whatever we call it, compression, quality assessment, and enhancement. So pre and post processing methods. The other topic that we explored recently was also greening of streaming. As part of this, since last week meeting, we had just one presentation, which was on robust perceptual similarity metrics for images and videos, given by Abhijay from Portland University, US. It was on 26th of February. We had previously a lot of presentations from MPEG systems for smart contracts for media by from the I apologize, I forgot the name. Then we had presentations on learned image compression. We also had presentation from Samira on sustainable and green video streaming. And last in-person week meeting, we had two presentations on 4K image super resolution and learning based image and video compression, and also panel discussions with G, Yanis, Richard, and Matthias. This meeting, we have 4 presentations which are scheduled right now. So the ETG session is on Tuesday from 3 to 5 p.m. British Summer Time. So I think it's 4 to 6 CEST. So we have 3 presentations. The first one would be from Abhijay, which will be kind of an extension of the presentation that I gave last week meeting, which will be on assessing the quality of AI generated images and videos. So what are the new challenges that we are facing right now with this new AI technologies being introduced into multimedia chain? Then there is presentation. These are the numbers on the registration. So that's presentation 126 is on augmented reality heads-up displays and digital rear view mirrors in cars by Shell. And then we have presentation number 137, which is on energy aware spatial and temporal resolution selection for video streaming. And then Wednesday, we will have in the last presentation scheduled on Wednesday afternoon session is presentation number 142, which is by Matthias on updates on testing activities in MPEG VQA. So these are the scheduled presentations in this group. And then we just wanted to also mention about an upcoming challenge in ECCV AIM. So ECCV is in Milan, end of September, start of October this year. So we have a challenge here, which is called the USD IQA challenge, pushing the boundaries of blind photo quality assessment. So the main goal of this challenge is to predict the subjective quality of high resolution images. So these are typically captured images without any introduced distortion. So these are typically on the higher range of the quality scale. The data sets that are being made available consist of over 6,000 images, which we have split into training, validation, and test. And you can see the split for these. So the training and validation images are available along with the MOS ratings. So to train and validate your models. And the test set will be released later with just the images, not the MOS ratings, and will be used to evaluate the challenge winners. There are exciting prizes for this, and if anyone or if you have a model for no reference or blind image quality assessment, please feel free to participate here. So the competition winners and runners up will receive from a pool of 2 PS5s and 3 Sony headphones. So these are again contact details of myself and Saman. And if you have any more questions or comments, feel free to reach out to us. That's all from my side. Again, so apologies for the CGI. We might have a presentation, but it's not registered yet. But there was a request for that via email. So I'm not sure if for CGI, if that would go forward. But currently we don't have any presentation scheduled for the CGI session. Any question?
Yeah, go ahead.
No, just any questions or comments? If not.
Yeah, doesn't seem to be in the room. Thank you so much, Nabajit. So, share my screen again. So then I think we move into Norm. I will just check the schedule here on the. As you can see, the sorry. Let me see. Where did it go? Okay, let's move on to the Norm.
And I guess that would be me, like the libero at the football game. So yes, as you know, Margaret is not able to make it, and given also the time zone, I'll present the high level of Norm. I am one of the co-chairs. So Norm, no reference metrics, tries to do exactly what the title says. So establish objective and subjective methods, primarily on the objective front, obviously, to assess quality for images and video. We have not a fixed cadence, but we tend to gravitate again around once every 4 weeks. The main topic for these past 6 months was triggered by the reference from Chulhi Lee on the renewed interest within ITU to make a no reference metric standard. So we had these like preparatory meetings to understand how can we bound the problem in a way that has a maximum chance of success. And in doing so, we had the opinions come from academia, industry, primarily industry. And I can say that we are converging that the VOD use case, where we're going to focus on the, like scaling and compression artifacts, also trying to include some of the capture artifacts that appear primarily in UGC content, is the scope of where we'd like to focus. So that's really the high-level summary I can offer. I did not do a full count, so if you go back to your list, I think there were like 4 presentations scheduled this time. Can you confirm?
Sure. Into those tabs, I will find it again.
And again, Margaret Pynchon is the chair, and I'm one of the co-chairs.
So we had Norm Wednesday afternoon. 3 presentation there.
Okay. I guess I miscounted one. Okay. And again, back to you, so.
Sorry, Johannes, I had also a presentation that was removed. I don't know for some reasons, but I will combine it with 144 and I will have 1 presentation.
Yeah, maybe that's why I counted 4 today. I thought I saw another one.
But yeah, it's okay. I will combine it with that and I will have 1.
We'll figure it out. I think we have plenty of slots. I'm looking forward to your presentation, by the way. Okay, and if there is nothing else, back to Shao.
Okay, thank you, Yanis, for doing all the updates of several projects. Then we have the implementers guide for video quality metrics.
Actually, I think I can say something because in past meetings, we decided to merge it with the JAG Hybrid, which is the next one in the list.
So will you take the whole, update?
Yeah.
Okay, go ahead.
So, well, starting from JAG Hybrid, actually, the JAG Hybrid started with the idea of developing a no-reference hybrid perceptive stream model. But as we said many times, we gradually evolved into something a bit different. So basically taking new research questions, hopefully with a long-term impact on video quality research. So at the moment, we are not anymore seeking to develop a new metric or tool to perform video quality assessment, ready for use. And but we are basically doing some research in this field. And in this meeting, we will have 4 presentations by my former PhD student, Loic, which is now online, I think. One is about AI observers. We call them artificial intelligence-based observers, which are basically deep neural networks that try to predict the quality as perceived by single observers when we do subjective experiments. And then there's another one that is about the recovery of ground truth values from subjective quality experiments. And in this we've already presented it in last meeting, but in this time we have a few new results about, especially focusing on crowdsourcing, because the model that we presented we thought it was very suitable for crowdsourcing. Also, Margaret last time suggested this, so we tried to extend it for crowdsourcing. And another presentation that will be given by me is more about the status update in JAG Hybrid. And basically, we're trying to put together a new data set with high quality images, full HD resolution or more, and to be used in training a deep neural network based systems, starting from high resolution images and not only from small resolution ones that is mostly done nowadays with the deep neural networks approaches. And also I will give you updates indeed with the IGVQM group, so the Implementers Guide to Video Quality Metrics. And actually we are proceeding a bit slowly because I didn't find enough resources, especially as students before working on this until now. But we have a list of data sets available for which we are computing objective quality measures. And I will present a few results that we already have on a couple of data sets. And I will try to show you a roadmap of what we can do in the next 10 months until the next face-to-face meeting. And that's the final presentation that was put in JAG Hybrid. I think it's very suitable for that because it's from Maria, which is about a study about the relation between PSNR and SSIM. And I think that's more or less all for JAG Hybrid. Unless you have questions, I've got to answer.
This actually not a question for JAG Hybrid, but just for the record, I see actually 6 presentations currently listed, not in the schedule here, but in the detailed list of presentations cell. So I think we need to understand how to add them, or maybe if there is no place, put them in a different group. But the count is actually 6 norm presentations right now. And again, I'm looking forward to Enrico to the IGVQM presentations because I think it's an activity that is long overdue. Thank you.
Yeah, thank you, Yannis. I think we could. You're talking about those that have not been scheduled yet.
Exactly.
I was. Margaret has been mostly doing the scheduling, and maybe when she comes online, we can sort this out where we best kind of fit them in. So, but yeah, good point. So then we have the quality assessment for computer vision applications.
Can I share some slides?
Yes, please.
Okay, so as I mentioned before, I'm Miko Elestruk and I'm one of the coaches of the Kakolia group. And the mission of the group is to study the visual quality requirements for computer vision methods. And basically the idea is that we want to investigate the quality in terms of not the human perspective, but the performance of the recognition tasks, especially if conducted by automated systems based on usually machine learning nowadays, but also other kinds of automated systems. We do not limit ourselves to machine learning. So basically, we initially, like a couple of years ago, maybe like a dozen of years ago, we started with the just recognition tasks and that were conducted by humans. But since there was significant progress since then on the machine learning automated recognition systems, then we also extended ourselves towards computer vision, and even right now we are like focusing mainly on the computer vision. Unfortunately, there was not a lot of activities recently. But before I go to this, just I want to let you know that we have 3 coaches here. Besides me, there's also Patrick and Lou. I know Patrick is not yet here, but I know it's here in Klagenfurt. I saw some pictures.
Yeah, we probably not. Yeah.
Yeah, so at this year we were also able to talk to Patrick in person when he's here again. And I'm only aware about 2 recent presentations, publications that can be related to this group. These are 2 presentations that I was involved in. 2 publications that I was involved in. The first one is this paper in the Electronics published like 2 months ago or so. And there's also another paper that has been just accepted at the conference that is published by my PhD student and also some colleagues from the but it's probably going to be presented at the next big meeting. Well, I'm going to make a presentation on the paper that I mentioned that was published in Electronics this Wednesday. The topic is the objective video quality assessment method for object recognition tasks, and it's the afternoon slot just after the lunch break. Okay, basically it's everything. So thank you.
Thank you, Nikolai. So as you said, we have the Kakovia right after lunch on Wednesday. So moving on to 5D KPI.
Okay, I will share a couple of slides too. I don't know if remotes can hear me okay. If not, complain.
Loud and clear, Pablo, loud and clear.
So the 5G KPI was also established a few years ago. I think it was in the Google meeting actually, 2018, I believe, not sure. Anyway, it's a bit to close the gap between the QE research community and the networking research community and industry in general. So basically trying to link a bit the performance indicators that are measured or available in the networks and the QE research on top of all the services on top. So there are a few goals around that. We did some track of the state of the art. We wrote a technical report that was published by TUT. And this is about the past, but we are looking at the future. So which will be the next slide, but just also to mention that I am the chair and Shell is the vice chair of the group. And yeah, so we have a nice session this afternoon. After lunch, it's established like in a workshop way, because we wanted, as we presented in the last couple of meetings, we are figuring out what to do next. We think there's an interesting opportunity in this definition of 6G to improve this connection between the network and the application. So yeah, the session today is, we are taking the whole afternoon in 2 slots. The first one is more a wide view of the state of the art of the whole problem. We'll have an introduction with Shell, then we will have a nice keynote by Michele Sorsi, remotely from Padua. Then another a bit smaller keynotes prepared by Tobias Hosfeld and myself. I will probably doing the presentation here locally, but he will be remotely as well available for questions. And then another one by Shell and Gunilla about the state of the art of the, more from the standardization and industry perspective. And after the break, we will come with industry more in a more focused way. We have one presentation from Francois from Meta, seeing the perspectives from the content and application providers. So basically what they need, what the Meta, Netflix, Google, YouTube, these kind of companies need from the network, let's say. And another one from Erin Halepovic from AT&T, presenting the other way around. So what the network needs from the applications and what can provide. So around PoE. And then we will have a discussion, panel guided, I would say. So we'll have, a short, small panel here with Francois, Enrico, and Christian that accepted the invitation to be here in the discussion, but we expect everyone else here, and especially online. We have a few participants registered online from Nokia, from Ericsson, from IoT Study Group 12, and others who could contribute to the idea of how we in BigWeb could be helpful to address this problem, which is a relevant industry problem. Really the relationship between the network and the applications, and how QoE can be better managed between both parties. So that's all. We will have everything, a lot of detail in this afternoon, a lot of food for thought. So please pay attention and contribute. You have a lot of time for discussion.
Thank you. Emerging Technology Group have already done their update. Then we have the Immersive Media group.
I will also share some slides. Okay, so the Immersive Media Group is the group focused on studying the quality assessment of immersive media technologies, covering the whole range of technologies that you can imagine: 360 video, XR, light field, HDR, etc. The goals are to provide quality of experience guidelines, both on evaluation and subjective testing methods and also objective metrics, and also to provide data sets for immersive media content. We have been working some years, and there was already a test plan, and that ended with a recommendation for quality evaluation of 360-degree videos. And now we are working together again with a test plan on evaluation of immersive and interactive communication systems. There is an active, an activity within 13 labs now, and we will present the status of this test plan on Wednesday. You have there the reflector, and we are 3 co-chairs, myself, Jesus, and Pablo, that is here also, and Selson Chen from University. So the plan, The plan for this meeting is to present, it will be the slot on Wednesday. We have this presentation that Paolo and I will do on how this test plan is going on. We will have short presentation on the status of the tests that are going on in each lab and some discussion and next steps that we are going to face. There are also some long, kind of long presentations of some tests that have been already finished that were covered in this test plan, one from myself and one colleague from UPM on subjective evaluation of immersive communication systems in a case study of a 3D video system, and another one from Felix from TU Ilmenau on subjective evaluation of the impact of spatial audio. And we will have two more presentations. I think these are the ones that Maria mentioned before on light field datasets and work on quality assessment of light fields. And also another one from TU Ilmenau on an open source audiovisual 360 video from Stefan Fleming. I think this is all. I want to invite you all to attend this session on Wednesday. I have also some slides from the simulation part of. Do you want me to continue? Or?
No, yeah, go on.
So there, there is this dissemination activity within BigWeb. We had the opportunity to report our activities in the ACM Special Interest Group on Multimedia Records. This is a quarterly newsletter that is open. You can check it in these links that you have there. It also has an ISSN, so it's a publication, let's say. One of these sections, or one of the sections of these records is related to reporting on the standardization organization. There are some columns on MPEG, JPEG, and also BigWeb. So we have this possibility to disseminate our activities in 4 times a year. What we are doing lately is to provide 2 reports on the plenary meetings, and then we have 2 other issues free for any other input that we can have from the groups. If you have any comment or doubts, please ask me or Shell. The last column was published last month, in May. It was corresponding to the issue in April, and it was a report on the plenary meeting that we had in December 2023 that was online but hosted by the University of Constance. I invite you to check it. We will also report on this meeting that we are having right now on the report in July, and then any other ideas on topics that we want to show to the community are more than welcome for next issues that we from September 2023. That's it.
Very good, thank you. This, I think, it's another dissemination is the e-letter. I think that it has been dormant for some time, and we kind of struggling how to revitalize it. So there is no updates there. So the current outreach activities is basically the SIGIM records, and thanks to Jesus mainly work to actually do these updates. I think it's excellent, but so we'll see if we can have other ways also to disseminate moving forward. Then we also have we are now in the support and outreach groups, and one of the important support group is the tools and subjective lab setup group. There anyone here that can make an update on that? No. So here is a repository for different type of tools that has been developed by WCAG members and put here to collected here for anyone to use. There are a number of useful tools, so check this out. And if you have something you want to contribute, we are more than happy to host it. Yeah. There update from the IRG AVQA. Sorry, I wasn't sharing. Okay, I don't hear anyone saying anything on IRG AVQA. So there will be a session for IRG AVQA on Thursday, and basically Thursday and Friday will be devoted to ITUT work and updates. So don't miss that. And the also what I showed about the WCAG tools and labs setup group. There is plenty of useful tools, as I mentioned. You can check it out here if you are interested, and please contribute if you can. So now we have basically gone through all the updates. We usually also have, if someone has anything to report from any updates from standards activities like MPEG, if someone is active there, could say something. Look at Christian.
I think Diaz is coming anyway, right? So he will give an update.
Yeah, okay, yeah. So let's wait for that. Alex, do you have any updates for ITUT? That you well?
I just want to give a logistic update that our liaison, the WCAG liaison to AOM is finally moving on, and I expect within July to have the relation formally established, in which case the metadata initiative that we concluded with the draft as part of NORM will finally move on, at least as far as AOM is concerned.
Okay, sounds good. Thank you.
Yeah, and maybe I can mention for ITU, there is not a direct work item together with WCAG at the moment from the question 14, right? Obviously, we see here the one from Chul Hee, which is spread across the Thursday and Friday for question 19. Question 14 traditionally has been working on these DASH/HAS related models, short-term and longer-term integration models, which have resulted in P1203 and P1204 standards. And there, P1204, that was a very successful collaboration between VQuake and Study Group 12. And of course, we would be very glad to establish a similar project, because I think this has really led to quite a push and also to really relatively strong models. And one let's say candidate modeling direction could be extensions of those models to HDR or new HDR models. Unfortunately, I cannot be in Klagenfurt at this time this week, and so yeah, it's a bit difficult to discuss offline with colleagues there to consider such an option. In any way, I think this would be one direction. Another is that we have launched a new work item on XR related modeling. I will also discuss this in the IRG AVQA meeting on Thursday morning. I will show a little bit about the ideas, and that of course is another one where we are closely planning work with the IMG project here in VQuake. I mean, that would be a natural connection where the IMG group has currently primarily looked into the subjective testing side, and traditionally Q14 has been looking into these modeling things in Study Group 12, and it would be, or it appears quite straightforward to also have a connection with IMG there. Thank you.
Thank you, Alex. I was hoping to be able to show the website of Qualinet, but it doesn't seem to be up. I could share a slide about. So just briefly, the Qualinet is a similar organization like VQuake. It started out as a European funded activity, a cost action, and then it when the funding was over, it has continued in a similar way as VQuake. It organized its work in task forces, and it usually have the face-to-face meetings co-located with COMEX. So there were one meeting in Karlshamn the 17th of June. We for our meetings, going through what happened in the task forces, the updates, and how to move forward. And so the last one, I guess, was also maybe if I would have mentioned this in the afternoon session, but so there is no task force as far as I know that works on this within the scope of 5G KPI, as far as I know, but there are others. But I was hoping to show you an updated homepage, but the homepage is qualinet.eu. So if you are interested in their work, so please go there. They have a few very successful activities previously. One is the white paper of quality of experience. The definition of it was originated from Qualinet. It's also about the quality of experience of immersive experiences, another white paper. There was also the collection of annotated quality databases, which is a very nice repository of useful data. So. Okay, I think that's it on. if there are any more updates to be done, we could, of course, go early to coffee break. If there are any person that has not introduced themselves coming late, we can have an update on that point. We have several online here that have not introduced.
Yeah. So if I made a count of 10 people online that haven't introduced themselves. So would you like me to call them out one by one?
Please go ahead.
Okay. So let's start, as I see, with Pierre Le Breton.
So hello everyone. So I'm Pierre Le Breton. So I'm working at Capacité, which is like a filial of the University of Nantes. So nice to meet you.
And we have Loïc.
I am Loïc Fortio from the Polytechnic of di Torino, focusing on the modeling individual quality assessment using neural network as well as statistical models. Nice to meet you. Later.
And we have Mohsen.
Hello everyone, my name is Mohsen Janadele. I am a postdoc at the University of Constance and I'm working in image and video quality assessment, especially GND-based quality assessment and crowdsourcing. Thank you.
And then we have Rakesh.
Hi everyone, Rakesh. I'm from TU Ilmenau and I mainly focus on video quality assessment and modeling. Thank you.
And I see Saman.
Yeah, hi everyone. My name is Saman. I'm from Sony Interactive Entertainment, so or PlayStation, and working closely with Nabajit and sharing or co-chairing CGI and HEG groups, basically.
And I see Dominic Keller.
Hey, good morning, everyone. Can you guys hear me? I hope
Yes,
so.
we can hear you.
Great. I'm Dominic. I'm from AVT at TU Ilmenau, and I'm currently focusing on viewing distance and 8K HDR topics. And I'm looking forward to seeing a lot of interesting talks.
And I see Zhenzhong.
Oh, yes. Yeah, this is Zhenzhong from Wuhan University. I'm mainly working on video coding and quality assessment. And I'm working on with some other co-chairs for this IMG group.
And I see Camille. Camille, I'm not sure if you can hear us. Otherwise, go ahead.
Yeah, so my name is Kamil. I'm doing PhD at IGH University of Krakow. And I'm also right now doing a research visit at Nokia. So it's nice to be here. Thank you for the opportunity. And I will probably share one presentation with Mikolai tomorrow.
And Dietmar, not sure if you can hear us. I know Dietmar is in a far location. So I see Burak.
Hello, today is the first day of my internship, and I'm gonna be doing an internship in the AGH University of Krakow on video quality assessment and machine learning.
Thank you. And unless I'm missing someone, again, Dietmar, and I did not recall hearing from Avrayoti even last time. So either Avrayoti or Dietmar, if you are there and would like to introduce yourselves, go ahead. Otherwise, back to you. So.
Okay, thank you so much, Yanis. So let's see the schedule. So since we don't have any more updates now, I suggest we go on an early break. I don't know if it's useful to start earlier or if Enrico, you want to coordinate with the online people. So what do you think, Enrico? For Jaeger Hybrid?
Yeah. Would you like to start now?
No, I was thinking maybe we go
So if you can, okay, good.
I will share the screen if you can.
You can see.
Okay, so let me start. So hi everyone. I am going to present this work that is basically a summary of an article that we recently published on IEEE Transactional Multimedia. And we are going to focus on the question of modeling the scoring behavior of subjects in a subjective test based on discrete scale. I mean, this question of trying to understand how people score in order to recover the subjectively perceived quality of a stimulus is something that is, getting a high importance within our community. And in particular, one of the most common idea is that of assuming that a subject have a bias and an inconsistency, right? And we are going to adopt this similar perspective, but our idea was to define a bias a bit differently than what has been done previously. In particular, in previous works, bias was assumed to be a single, a scalar quantity, just quantifying how the subject deviates from the average quality. Instead, here we will define it as the tendency to prefer one item of the quality scale rather than others. And the other difference with this in this work as compared to previous research is basically that we are not going to assume a statistical model of this opinion score, but instead we do a kind of high-level assumption and derive a model. So, I mean, there's going to be a number of mathematical formulas here, but just for the sake of completeness, I put them just to make the presentation itself complete. for people reading them after my talk. But let me introduce you quickly to the notation, by the way. So we will denote by capital I a set of stimuli, J a set of subject, K our let's say discrete quality scale, capital F a set of all the external influence factors that might influence the choice of a subject. Then RJI, for instance, will be the rating given by subject J to stimulus I. And NIK will be the number of subjects that chose opinion score K or the item K on the discrete scale when scoring the quality of stimulus I. Okay. So using such a notation, the mean opinion score can be expressed as you can see from Formula 1. Okay. Basically, what this formula is saying is clear that the mean opinion score is simply a weighted sum of the item on the quality scale. Now, what is the weight of each item when we want to compute the MOS? It's basically the choice frequency of that item. Now, we know that the mean opinion score is not very robust to noise in the sense that it gave to all subjects the same weight, although they are independent of the fact that they are reliable or not. So, but this formula here, can give us some inspiration on how to redefine the ground truth quality of a stimulus. In particular, in equation 2, we say, okay, let us define the ground truth quality of the stimulus I simply as a weighted sum of the items on the discrete scale. But now let us find new weights, right? Weights that differ from just choosing the choice frequency of each item. What is our idea behind finding this new weighting scheme? Basically, we can, the weight WIK that you see here, or let's say the importance of the item K when scoring the quality of stimulus I, could be interpreted as maybe, the ground truth probability of choosing that item if the subjective test, if all the subjects were perfectly accurate. So if you assume that there is such a model, then you can, build up the likelihood function that represent maybe how you trust your data, right? If you perfectly trust the data, you can define the likelihood function and try to optimize that likelihood function in order to get those weights. But we clearly know here that this is not the case for our subjective tests, where not all the opinion score are, let's say, accurate. So our idea was to say that, okay, noisy opinion score are opinion score that are surprising. We can define how surprising each opinion score. This CIK that you see at the end of the slide, it's our measure of how surprised is the choice of the opinion score K when scoring the quality of stimulus I. So basically the opposite of the logarithm of the choice frequency of that item. I mean, this is not something that comes from taking the logarithm of a probability. It's something very common in information theory to measure the surprise, right? Now, based on this definition of surprise, we can, if you look at equation 3, that is basically what we call the average surprise, right? Along all the data set. So the equation 3 here, it's a definition of what could be the expected surprise associated with the data that we collected. What we want to do in our determination of the weight is to say, let us maximize the likelihood while minimizing the surprise. So find the weights that define, that represent our ground truth quality in a way that they maximize the likelihood, so our trust in the data, while minimizing the impact of surprising events, okay? So by solving this optimization problem here, clearly the variables are W, we get the optimal value of this optimization problem here, how we obtain, okay, our W that we can then use in equation 2 here to get our ground truth quality. So for instance, if we are on the 5-point ACR scale, there will be for each stimulus 5 value of W, right? So the importance of each item on the quality scale. So this is how we obtain an estimate of the ground truth quality. Now, as I said before, we are going to follow the step ground truth quality, bias, and then inconsistency. Now, let us focus a bit on how we can define the bias using the quality weights that we just computed here. Before reaching that step, to better understand what we are going to do here, let me show you a list of some behavior that might happen in a subjective test based on a discrete scale. This list here comes from a paper that now I realize that I did not put on the slide, but yeah, it is not from me, but from a paper that has studied, you know, the behavior of observer in subjective test based on discrete scale. Now, the first two behavior are very common. They have been long studied in our community. So positively biased subjects as well as negatively biased subjects. Other behaviors are spammer annotators. Annotators that just tend to give random opinion score. Then there are competent annotators or just subjects that are very accurate, that do what we expect them to do, right? Then then there is also this adversary behavior. That means basically somebody that misunderstood the task, the task or how to interpret the scale. And when the quality is bad, the guy gave 5 instead of giving 1, so something like this. On the other hand side, you have behavior like unary, binary, and ternary. These behaviors here are those that will justify our new definition of bias, right? And in particular, a unary subject is simply a subject that tends to prefer 1 opinion score. The binary tends to prefer 2, and the ternary tends to prefer 3. Now, looking at binary, ternary, and unary, it is clear that we might define the bias as a lower level, like defining instead the bias as the tendency to prefer one item of the quality scale with respect to the other. And it is exactly what we did here. So we introduced this quantity mu kj, that stands for the tendency of subject j to prefer the item k on the scale with respect to the other item of the scale. Now, preferring item k means that you attribute more importance to that item when you are scoring, right? Remember, the WIK that we found before was the ground truth importance of each item, okay, in determining the ground truth quality. Now, we have a subject. Imagine a subject that gave 3. You can encode that 3 as 0, 0, 1, 0, 0. This encoding here, it's basically saying that it's basically giving you the importance that the subject actually gave to each opinion score. Now, you can do this for each opinion score of the subject and subtract this binary vector from the vector of weights that we got before and just average, right? This will give you the tendency, the expected tendency of the subject to prefer the opinion score K with respect to the other. So this is roughly our idea behind our estimation of the bias weight. Now, maybe from this very quick presentation, it might be hard to get this property that you see in equation 7. So for a given 7, if you sum all the bias weights of that subject over the quality scale, the sum will be 0. This means that there are certain bias weights that are positive and others that are negative. A positive bias weight means the tendency to prefer that opinion score, and a negative will mean the tendency not to choose that opinion score. Also, for comparison check, as I said before, previous approaches define an overall bias. We can also compute from this bias weight an overall bias by simply weighting each item of the scale with the corresponding bias weight, okay, to get the overall bias of the subject that we might compare with the bias computed by software such as Surreal to just see what happened. Now, we have done with quality, we have done with bias. Now let us move to inconsistency. In order to compute the subject inconsistency, you basically need a statistical model, right? Now, let us not assume that the rating of the subject comes from a particular probability distribution, but instead, let us make this kind of, I will say, let us follow this idea here. We follow the idea that when I ask a subject to rate the stimulus I, the subject unconsciously basically assign an attractiveness to each item of the quality scale, and then just pick the item with the highest attractiveness for him. So it is something that is done unconsciously. Okay. How can we define such an attractiveness? First of all, it needs to depend on the actual quality of the stimulus that is being rated. It needs to depend on the subject tendency to prefer certain opinion score rather than others. And finally, there are external influence factors that even the subject cannot control. Okay, so we therefore, taking into account these three components, we define the attractiveness of the opinion score K for subject J when rating stimulus I as the sum of what? The importance of let's say the importance of opinion score K in determining the quality of stimulus I plus the tendency of that subject to prefer that specific opinion score plus a random variable modeling external factors. Now, obviously, it is super hard to know, what is the right priority distribution for this random variable, because there are a lot of influence factors, and it will be super complicated to, to just hypothesize that this follow a normal distribution, a uniform one. So it's super hard. Okay. We don't want to therefore to assume that it follow a specific priority distribution. Any assumption will kind of be arbitrary. But instead, there is a lot of math here, but again, it is just to be complete. We cannot go into all the detail. Let me explain what we want to do with that variable, the assumption we want to put on that variable. Equation 10 here is asking that variable should belong to what is known in statistics as the Gamble domain of attraction. And the variables that belong to, there are a lot of random variables in that domain of, in that Gamble domain of attraction. It includes the normal distribution, Gamble, logistic, exponential random variable, and so on. So it is a family including many random variables. In general, they are known in statistics as random variables that have heavy tails. Okay, that decrease the tail of the for which the tail of the distribution decreased very fast. So what I'm saying is that we assume that the influence factors have a heavy tail distribution. That is a distribution that decreases very fast, and this includes a lot of distributions that are of common use, normal, logistic, and so on. Okay, so under the assumption that the stochastic terms characterizing the influence factor, the external influence factors, belongs to that family, and obviously that family is not at all restrictive. As I said, it includes a lot of distribution of common use. Under this assumption, we can derive our scoring model that basically says that the probability of subject J to choose the opinion score K when scoring the quality of stimulus I can be expressed as is follow. Okay, this is our scoring model. It's a theorem that we prove in the paper. Okay, you can have a look at the paper to see, but you can see that this probability here depends on the quality of the stimulus to be read through W, the subject bias through mu, and finally a parameter beta J. Note that beta J is indexed by the subject, right? It's indexed by the by J. So let me go back. Beta J come from this equation here that characterize the let's say the distribution of influence factor. So the stochasticity or the uncertainty. So in fact, this is a first evidence that beta J, this parameter beta J, characterize the subject inconsistency. You don't believe that? Let me give a better evidence. Look, if beta J goes to 0 in this formula here, the numerator will go to 1 and the denominator will go to the total number of items on the scale. So a subject for which the parameter beta 10 is very small, it's a subject choosing the opinion score with probability just 1 over the total number of items on the scale. So it's subject scoring at random. But obviously, we cannot just take beta as a single indicator of uncertainty. We have the whole probability distribution regarding the way the subject is giving his opinion score. We can just take the variance of that probability distribution as the inconsistency of the subject J when rating stimulus I. Okay, so in equation 12, we are defining the inconsistency of subject J when rating stimulus I as the variance of the random variable modeling his opinion score for that specific stimulus. Now, again, for the check of comparison, we can define the overall inconsistency of subject J as the average of his inconsistencies for all the stimulus. Okay, we can take the average. I mean, here we are assuming that the subject is scoring each sequence independently. Otherwise, the computation might be very complicated because we have a mixture here, not just sequence of independent random variable. Now, to get this probability here, we need to estimate the parameter beta j, right? What we can do is basically try to map the theoretical. This is our theoretical variance. This is the theoretical variance of the subject. We can compute the. Sorry.
No.
Okay. We can compute the empirical variance by just taking the ratings of the subject, subtracting the grant of quality, and taking the variance of this residual, and just find the beta that minimize, the difference between the theoretical variance and the empirical one. So this is our way of calibrating beta, okay? Beta j. Now, during the last VQuake meeting, I already presented, part of this work here and discussed the usual results on how robust is this new way of estimating quality with respect to existing approaches in terms of, synthetic noise added to the data. So allow me to, not turn back on this in this presentation here, but instead, let us see a bit, discuss a bit about the potential of, this approach to highlight peculiar behavior in subjective tests. And let us start with a test conducted in a lab, right? And in particular, we took the Netflix public data set, that is basically a data set with 70, I think maybe 70 stimulus and 26 real subjects. To these subjects, we added, we simulated, some of the peculiar behaviors that I told you before. In particular, here we are talking about unary, binary, ternary, adversary, spammer, and another behavior that we call bimodal. A bimodal scoring behavior, it's simply a subject, that when the quality is satisfying to him, he tends to choose opinion score around bad. So he forms a normal distribution around bad. When the quality is not satisfying. When it is satisfying, he's formed a normal distribution around good, okay? So a kind of quantization of the quality scale. So now we try to simulate these peculiar subjects and added them to the data set. So at the end, we had the 26 real subject plus the simulated subjects. Then we apply the Surial software to compute the bias, the overall bias of all subjects, as well as the inconsistency, and also computed the overall inconsistency and overall bias using the formula that I showed you before with our approach. The figure A and B here show you the comparison between the bias and inconsistency computed by the two approaches. You can see that there is very high correlations between the two approaches, okay? And the only information that we can see from this chart here is that, for instance, the spammer as well as the adversary are highly inconsistent. Also, the unary subject is inconsistent, as well as the binary. With real subjects, we also see that subject number 6, 7, and 14 are inconsistent. But everything stops there. We have no way to understand what is the source of this inconsistency, right? Also, subject number 10 is highly biased, but we have no, if we stop there, just basing on the bias and inconsistency, we have no more information to understand the source of that inconsistency or the bias. Now, remember, we introduced the so-called bias weights, right? So for each subject, we have 5 different bias weights. And the heat maps here that you see here is showing the bias weight for each subject, including the simulated subjects. Let me, again, what I want to remember, subject number 10 was very positively biased, right? Okay, subject number 10 was positively biased. We can see from the bias weights and matrix here that it's a subject that tends to choose excellent too much with respect to the other opinion score, okay? So it is not a kind of bias for which we will say that when the quality is bad, the guy choose poor, and when it is fair, the guy choose good. No, it is a bias that comes from from a high tendency to use the right part of the scale. Another interesting thing that we can see was that subject number 6 was inconsistent, right? And what we can see is that subject number 6 tends to favor the extreme of the scale. So it's not very pronounced, but a kind of, binary subjects. Subject number 7, instead, that was also inconsistent, tends not to use excellence because you have a negative bias weight, but instead of compensating this by choosing good, he tends to choose fair. So there is a gap, right, in his way of rating the quality. Okay, so these are initial, initial points, initial analysis that you can do with how you can use the bias weight to interpret the source of inconsistency, right? So, and also, if we look at the simulated subjects, they appear with the patterns that we might expect, right? You see that the unary, binary, and ternary, and also bimodal, respectively, have 1, 2, and 3 opinion score that they tend to favor. So the simulation basically show that our bias weights are doing what they are expected to do. Interesting enough is also the fact that we had the inconsistency per stimulus. Okay, if we take if we turn back again to the statistical model behind Surreal, there is an average inconsistency, right? So for at least by design, the model does not didn't think about like I won't say think about, but the model does not consider the possibility to basically analyze the inconsistency of the subject, depending on the quality of the stimulus that we are rating. Instead, with this approach here, as we have a measure of inconsistency for each stimulus, we can take the average based, on the quality scale, like what is the average of the average inconsistency for all stimulus for which the recovery quality is smaller than 1.5, and then between 1.5 and 4.5, and so on. And what you see on the heat map at the left, it's basically what is known in the quality assessment community as the source, let's say the source hypothesis, or the lower inconsistency of subject at the extreme of the scale. So despite we didn't, model that, we didn't put that explicitly, the scoring model that we derive under that assumption, under the assumption that subject attributing attractiveness to an item and pick that item with the high inconsistency, this model is able to mimic the subject lower inconsistency at the extreme of the quality scale. Now, during the last week meeting, there was a suggestion from Margaret saying that this tool here could be, quite interesting to analyze, in particular, crowdsourcing data sets. Okay, let me move this here. And what I did is that I tried to apply this approach to 2 crowdsourcing data sets. And the first one is this CONVID 1K video quality assessment database, okay, including 1,200 short video sequences rated by 624 people observer. This one is a data set on quality, focusing on quality assessment, 5-point ACR scale, right? I don't remember exactly whether it is double stimulus, but yeah, but it is a 5-point scale. The second data set that I have considered is this MovieLens 1M data set that is not focusing exactly on the quality assessment tags, just asking people after watching a movie to give the overall satisfaction with the meeting. Okay, so it's a quality of experience data set, but not necessarily focusing on quality assessment. It was just important to specify. On this data set, on these 2 data sets here, we apply again our approach, okay, and try to figure out how frequent are some of the peculiar behavior that we discussed before, and also try to see whether, if we focus on the bias and inconsistency and disregard bias weights, we can identify this peculiar behavior. Let me move to the first behavior that we analyze. In particular, we try to analyze the frequency of unary patterns. What is a unary pattern? Again, is a subject for which only one bias weight is positive and all the other are negative. Okay. What we have seen is that 16% of the subject, on average, right, for both data sets, 16% of the subjects show with this pattern, the unary pattern. And I'm just showing to you, the matrix showing the top 40 subjects with the unary patterns. Why for the data set following on quality, you see that the most, the subject that are mostly unary tends to just choose fair, right? Maybe a guy that just wants to complete the test as quickly as possible and insisting in choosing fair, not to offend anybody. Why it comes to the data set to the data set on, again, just overall satisfaction, many person tends just to give excellence. And this might just be, just saying, I have watched a movie, lose my time to watch a movie. I don't then just want to say it was not good. And yeah, maybe there's some condition here when you are scoring for this particular task, but we might discuss this later. So this was about the maps. But more important is that I am plotting here, I am showing you here the histogram of the inconsistency values as computed with Surial compared to, the blue histogram here, it's related to all the subjects, and the red histogram here is just the inconsistency of the of subjects showing a unary pattern. You see that there is a large overlap between the two histograms, right? Indicating maybe that the average, a unary subject with unary pattern are not more inconsistent on average than all the subjects. So, okay, and that is not a good information for us. Again, it means we need more information than the overall inconsistency to analyze, subjectively annotated data set probably. That is. Okay, we also analyze the binary pattern, that is subjects that tend to choose to like extreme opinion scores. Again, you see here the two heat maps. And in this case, the overall inconsistency, it's kind of a nerve because it seems that binary subjects are on average, there is a small shift between the two histograms. The overall inconsistency, it's enough maybe to claim that subjects there is a problem with these subjects here. But in order to see what is the problem and understand that the problem comes from the fact that they are mainly preferring the extremes, you need maybe again the bias weights. In terms of frequency, this behavior seems not to be too frequent. On average, we saw 2% of the subject show this pattern here. Finally, the bimodal behavior I told you about, that is subject that quantize the quality scale. They just want to rate everything like using, 2 focal points here. They put 2 focal points on the quality scale that are poor and good. And if they are satisfied with the quality, they tend to choose a uniform, give an opinion score that comes from a normal centered on good and poor. And when they are instead satisfied, they use a normal centered at good. Now, obviously, these are not bad subjects but there is still an issue. They are quantizing the quality scale. What we see is that if you focus on the overall inconsistency, you will not be able to distinguish those subjects from others. You need the bias weight to spot out the fact that they are quantizing the scale, right? This is, in terms of frequency, they are a bit more than binary, 4% in the two data sets that we analyzed. Yeah, in conclusion, we see that positional bias weight or they can bring more information to complement what inconsistency and bias already brings, okay? And the scoring model that we come out with here, it's able to capture the lower inconsistency of the subject at the extreme of the quality scale. And we have seen also the potential of this approach here to highlight, peculiar behavior also in large-scale data set as crowdsourcing one. The question of interest that are still open, you have seen that we estimated the quality by itself, the bias by itself, and finally the inconsistency. We just want to find, a stable way to just put the model that we got on table and use a single approach, to also estimate all the parameters, even though they are too much. Okay. So thank you for your attention. I would like to get from you any interesting question, any interesting suggestion to improve this work, or any question that you have. Thank you.
Okay, thank you. If there are any questions from the audience or online. Yes, please.
Just to confirm, the purpose of your study, was it to correct subjective assessment or subjective scoring with the remove the, I guess, the errors or remove some of the extreme cases? Was it the main purpose of this study?
Yeah, I will say, I mean, correct is a very big word, but yeah, let's say that is the ultimate goal, right? Trying to mitigate the effect of noise on the raw opinion score that we collect. Yeah, mainly in crowdsourcing experiments, and yeah, and also some, few cases that might happen in lab experiments. Yeah.
You think, and are you satisfied to the models you created so far, or there is still more work to be done?
Let's say that up to a certain extent, it is pointing out some behavior that were maybe hard to see with existing things. So I am satisfied in that regard. But regarding the fact that we are still, estimating each parameter individually, we are not clear. We are not therefore able to say whether this model really fit the data. And so on this particular aspect here, I think that we can still improve.
And can you show again the slide that has the number of samples? I think I saw 600 subjects or 1,200 videos, or
this one here, you mean?
Yeah, okay. So you did that on short form videos and movies?
Yeah, this data set here collected the opinion score of these subjects here on the, I think it was 10 seconds videos, if I'm not wrong. Yeah, this should be 10 seconds video shown to people, asking them to express the opinion score on the quality. Obviously, being a crowdsourcing experiment, not all the subjects rated all the 1,200 videos. So again, I don't have all the details on this data set here, but being a crowdsourcing test, it was interesting again to analyze to see whether, there are some peculiar behavior. And in particular, I was quite surprised to see that there is a subject like the first subject that you see on this row here that basically accept to participate in the test and really, almost all the time choosing that saying the quality is fair. That was the kind of information that we wanted to know. Like, you never know. You might know this after your analysis. You might visualize this, and again, if the person is at hand or available, you might want to tell him what was the issue with his evaluation and maybe ask him if he wants to, it's a kind of post-training, right? See what happened during the test and potentially ask the guy if he wants to do the test again, or in the case he cannot do, you are aware of what happened and decide whether you want to keep him in the loop when using the data, or if you decide how to keep him in the room, you will decide how to mitigate the effect caused by this high tendency of the subject to choose fair. That is at least the goal behind the whole job here.
Here.
You're welcome.
Okay, yeah, please.
Hi, Lord, this is Pablo. I have a couple of questions. So first comment is that about this large databases in general. So especially about the MovieLens database, is somehow known that rating QoE and rating like movie overall satisfaction is different in terms of distributions. So it's nice that your tool captures both behaviors, but we should not expect both behaviors in QoE tests. This this was actually, so from the first SOS papers from Tobias Hosfeld did this analysis that you can take this SOS hypothesis in QoE modeling because of the nature of the QoE evaluation, which is different than the nature of the movie satisfaction evaluation. So this is one short comment. Second short comment you have probably thought about, but if you want to see if this user behavior is really per individual, like as a person, you could check the database of the experiment that we did a few years ago of having people rating 10 times the same sequences. So you should get, if you run your tools there, you should get if these individuals consistently behave in one way or another across, repeating 10 times the same experiment. Third one, and a bit more like long-term vision, is that I would suggest to check the usefulness of the approach. Let's say maybe by comparing like the same experiment doing in a crowdsourced situation and in a lab situation, and see if you get different patterns, and if by cleaning your data with your tool you could improve the results somehow, and you probably need to define a metric of improve, or maybe there's in some, maybe they have some suggestions on how to how we can say that we have improved a subjective experiment. But somehow I would expect in the next in a COMEX in a VCOG meeting of the future to see your next presentation about comparing this on the same PVSs but into two different scoring types. That will be a very, very nice experiment if you have every time to do it.
Thank you, Pablo. Yeah, these are all very nice comments. Yeah, thank you.
Any other question? It was Patrick, right?
Yeah.
Luca speaking.
Yeah, Patrick.
You have comparison with a graphical probabilistic model proposed by Ling and his colleagues, which is a bit similar to what you want to measure. Did you compare with this type of model?
No, that is a great point, Patrick. Again, I'll mainly focus it on comparing it with model of the same family, focusing on bias and inconsistency. But yeah, definitely I will see. I am fully aware of your paper. I will indeed like to see ask you if you see other than comparing the robustness to noise, the usual robustness to noise. Do you see I was wondering struggling to understand how I can compare this approach to the graphical model that you are talking about in terms of identifying peculiar behavior.
Yeah. Yeah, because this is what you get at the end of the day, right? You find some kind of behavior, and the GPM is exactly what it is about. But forming few classes and eventually you could extend this more classes that you have identified for your framework. So I think it could be very valuable.
I think I will get in touch with Ali to figure out, kind of the best way to, compare the two models, find similarities and dissimilarities. And so, yeah, definitely agree with you that we need also to go out of the score, the score of bias and inconsistency, taking more general idea than the one that is behind the graphical model, yeah, that you propose.
Okay, thank you. Any more questions? If not, I don't see any questions online. So I think you can move to the second presentation. Maybe a bit past the schedule, since we already spent 4 minutes. Okay, thank you. Go ahead.
Okay, so let me put it full screen. Just let me know when you can see my full screen.
Yeah, like full screen. Right.
Nice. So again, this is our second presentation. Now we are still going to focus on modeling individual behavior, but this time not with a statistical model, but rather with a neural network. And it is a summary of a work that we recently published on ACM Tom. But let me start with the general idea that we are focusing on in the JEG group. The idea is that of training a neural network to mimic the quality perception of an individual subject. And what is the idea? The idea is to train a neural network and then maybe focus on the the softmax layer of that neural network as a representation also of the uncertainty that characterize user scoring behavior on the ACL scale. So the scope of this, we kind of see a long-term goal for this research here. We don't see immediate application right now, except for the fact that if you can predict individual opinion, then you can compute all the metrics that you like. Okay, you can go beyond all the indexes that we have been predicting in the community if you compute individual opinion score. On the other hand, as a long-term goal, we foresee a kind of feature where maybe on Peter's smartphone, there is a model, an artificial intelligence-based model that represents Peter's perception of quality, so that maybe an image or any media is displayed to Peter based on his own expectation. So this is our ultimate goal in this analysis, making sure that we get rendering system maybe that embed individual characteristics. Now, what is complex with this research here as compared maybe to most prediction? The problem is that individual opinion score are far more noisier than the mean opinion score. So we are considering a learning task with noisy label, and this sort of tasks are data demanding. Fortunately, we don't have this data. So the only thing that we can do here is to refer on tools like transfer learning or data augmentation. And in that sense, we have proposed a kind of training approach called human in the loop that we have been using so far. Let me quickly introduce you to this HLT or human in the loop training. The idea is first to build a synthetically annotated large-scale dataset on which we pre-train a neural network. Now, once this step is completed, let us assume that we want to train a neural network that with the hope to mimic. I'm saying mimic, but we train for prediction, hoping that it will mimic. Prediction and mimicking are two different concepts, right? So we want to train a neural network to mimic Peter. And what we do is that the second step of HLT after pre-training this network is to invite Peter, that is the subject you want to model. We invite Peter in a subjective test, ask him to rate like the quality of 500 video sequences chosen with the usual ITU recommendations, use the rating given by Peter to continue the training of the pre-trained network. This network the network that we obtain after this first transfer learning step is tested on a very large scale dataset, obviously without subjective annotation. We test the network. Remember, the network for each image predict a probability distribution. We can use the variance of this probability distribution to understand how confident is the network with respect to its assessment of the quality of each image. So once we test this network, we can order the image based on the confidence of the network and select a new set of 500 images. Okay, those for which the network is not very confident, to turn to step 2 again, showing this image to Peter, rate them again, and we repeat until as long as we have Peters available, or the network this procedure converges. Okay, but in general we stop due to availability, not yet convergent so far. So the dead NN obtained at the last iteration is basically the network that we believe should hopefully mimic Peter quality perception. Now, I talked about building a synthetically annotated dataset to train a neural network. What we have done so far is that we have trained a network called multi-distortion ResNet 50. We have pre-trained a network called multi-distortion ResNet 50. And it is basically a transfer learning step on the typical ResNet 50, but done on a dataset for image quality assessment. And this dataset for image quality assessment is synthetically annotated dataset. How did we get that dataset? It is a dataset including 2 million images that were obtained by selecting 100,000 high quality images from the ImageNet dataset and applying to each of these images 5 different levels of 4 distortions: noise, blur, JPEG, and JPEG 2000 compression. What are the labeling rules that we use it? The labeling rule that we use it here, sorry, I wanted to zoom a bit to show you something, but yeah, the labeling rules that we use it are in this table here. For instance, when we apply, let's say, when we apply a Gaussian noise in this whose sigma is in this range here, we label the image as bad, and so on. So maybe you can see, you can get more of the more on this on the paper. I will just get out to zoom again, but you can. I was saying you can get all of this rule in the paper that I will present in a while. And this rule here comes from an analysis of 2 small-scale subjectively annotated datasets. So we derived this rule from such an analysis. Okay, why did we do this preliminary step to take the ResNet 50 and train it again on a quality assessment dataset? The point was to obtain a network that is already able to extract feature for the image quality assessment task, rather than starting from a network that is trained for image recognition. Okay, to show the effectiveness of that preliminary step, we took our multi-distortion ResNet 50 and the ResNet 50 itself. We gave as input to both network images with different type of distortions. Take the features computed at the last layer, at the last convolutional layer, okay, that are of high dimensions. We use the so-called TSNE map to reduce this feature to a 2-dimensional plot. And what you can see to the right here is that the multi-distortion ResNet 50, it's able to distinguish about the different distortion. It's no more a network that extract. It's no more a network that extracts feature characterizing objects in an image, but rather a distortion-aware network, something that the ResNet 50, the original ResNet 50, cannot do. So, from our point of view, this multi-distortion ResNet 50, that, by the way, we made it, we released it in case you want to use it as starting point rather than the ResNet 50. We release it. We believe that the multi-distortion network could be a better starting point for transfer learning in image quality assessment tasks. Now, this was the discussion, our first training step. In fact, sorry?
Like, maybe you should speak closer to the microphone, closer to the computer, please.
Okay. Okay. Sorry. So, in the first contribution that we presented at VQuake, we started from that network and applied 3 iterations of HLT, of human in the loop. So we invited the subject 3 times to get your AI observer. I've already presented that contribution here at VQuake. So I will rather focus in a second contribution that we recently published on ACM Tom, in which we unfortunately were able only to apply a single iteration of HLT because we use existing data sets and we weren't able to invite again observer that gave the first ratings. So let me share with you some results here. First of all, let us compare the AI observers to real observers in terms of multi-distortion assessment. Okay, the table is showing the correlation between the ratings of real subjects, let's say, between the ratings of subjects and the MOS. Okay, in particular, you say that the correlations here go from 0, except for subject number 14, that is clearly, we have seen it to be an outlier. The correlations goes from 0.81 to 0.93. Now, in the heat map, we correlate the opinion score predicted by the AI observers to the MOS. And in general, you see that a lot of cells are rates, right? The rates here stand for correlation above 0.8. So there are a lot of observers for which the correlation of the accuracy of the subject of the AI observers in predicting the MOS is in the same order of, of magnitude of the correlation between the rating of real observers and the MOS. So this it's a result that say, okay, the AI observer are good enough for prediction. But what about mimicking? By mimicking here, I intend what can the air observer do something that they are not trained for? Okay, they are trained for prediction, but now can they mimic other aspects of the of the scoring behavior? To this end, what we have done, we did some simulations to verify what a neural network can mimic, okay, from a subject. What we did is that we took this scoring model here again that assumed that an opinion score comes from quality plus a bias plus a normally distributed error. It's the model behind Surya, right? We used it to simulate the opinion score of subjects in a way to know exactly what is the bias of each subject and what is the inconsistency of each subject. And so we took data set for which for each image we had the most. We basically use the most as an estimator of the ground truth quality. Okay. Now the question here was to train to use HLT or one iteration of HLT to train a model to simulate, to represent a subject for which we know exactly what is the bias and the inconsistency. The figure here shows you the correlation between the bias of the air observer and the bias of the subject we simulated for two different data sets. You can see that there is great correlation independently of the value of the inconsistency of the subject. So whatever when we set the inconsistency even to 1, we still have correlation between the bias of the air observer and the bias of the subject. So in short, we say the network will still mimic the expectation of the subject independently of his level of inconsistency maybe. And what happened for the inconsistency? Also here, the correlation is not as greater as in the case of the bias, but still there is correlation. How do we find the inconsistency of the air observer? Remember, the air observer takes as input an image, and the softmax layer of the air observer predict a 5-class probability distribution that represent for us, the overall, the level of the variance of this probability distribution give us an information on how confident it is the air observer regarding his assessment of the quality of the input image. Now, in general, for many computer vision tasks, there is not correlation between human confidence and model confidence. What we have seen for this particular task here, it was quite surprising, it was that there is correlation. Okay, I repeat, we just trained the network to map, the input image to the opinion score, but then we see that there is correlation between these different characters here. So this result maybe suggests that the network softmax layer can simulate the subject confidence or the subject inconsistency. And also the bias can be simulated. But can we do more than that? This is a question that we are still investigating. Okay. And in particular, we want to see whether the network can model the preference of a subject, despite we know that real data sets are very of small scale, right? And we can do it again with simulation. We are trying to do it now with simulation, not putting a permanent bias as we did in the previous experiment, but rather putting a bias on some content, maybe content like football, we put a bias on it and see whether after the training of the network, by applying the network on a different data set, the network tends to say, oh, this guy likes football, by the way. So when he asked it to rate image on football, he doesn't rate the quality, but he rate the type of content actually. Also, we like to understand whether the network, learn something about the aesthetic perception of the rated subject. If I say that, oh, this blurring part here is just an artifact, it's an aesthetic artifact, will my air observer do the same? So these are questions that we are investigating. We just want to train for prediction, but check later whether the networks, mimic something. Now, another aspect that we're interested in was to understand whether the sensitivity of an air observer to certain situation is similar to that of real observers or to that of subjects. So what you see here, it's a set of 5 images. We took a nice, nice image in general. We reduced the saturation in color, and we wanted to know, in general, let me put the assumption. The assumption here is that if we train a subject to assess the annoyance of blur, noise, JPEG and JPEG compression. That was the scope of our work. Then a subject that is shown these 5 images here, not at once, right? In a single stimulus test, we show them one after the other. The subject is probably going to give similar opinion score, similar and probably a high opinion score, because there is none of the artifacts he's trained to assess. Okay, and then what happened is that when we gave, imagine we gave this file, if you get, we did this from several images and then feed them to the network. We expected an AI observer that simulate this the subject sensitivity. We expect a neural network that simulate the subject sensitivity to come out with a curve that is more or less, you know, constant. Okay, for these 5 images here, independently on the level of desaturation. What happened is that when we took state-of-the-art AI observers and used them, okay, to different images, we see that in general the opinion score of the AI observer decreased as the desaturation increased. On the other hand, we therefore train our AI observer by, you know, giving the same opinion score, forcing the network to have the same opinion score for images to which you apply the desaturation in this case. And then when testing the trained AI observer with this data augmentation approach, we get that, you see, in general, the curve at the right here, you see that the curve of the new trained AI observer is more or less constant, rather independently from the level of desaturation. I mean, we did the same analysis of sensitivity for noise, right? Again, this time, if the subject is trained to assess the annoyance of noise, we expect that when seeing these images here, an accurate subject progressively see that the quality is decreasing. What happened? We took existing AI observers, okay, and give the network, give them to the network, and it happened that they are seeing a constant quality. Okay, why? In the training, we therefore come back in the training of our AI observer, of the new AI observer. We basically, you know, computed. I mean, I don't have time to explain all the details, but we kind of find an optimal variance for of the noise to apply in order to make such a noise maybe not perceptible. And we added this kind of noise, give the same opinion score to the image, to the alterated image, and then retrain the network with that assumption. The idea here was to obtain curves for which before, you can see that basically applying a noise with a standard deviation of 0.05 should not degrade so much the quality, should not impair so much the quality. We are expecting curve like maybe the curve that you see from this guy here, for which before a certain level of before a standard deviation of 0.05, you expect that the quality is stopped and then decrease very drastically as the standard deviation of the noise increased. I mean, what I want to say here is that the pattern that we see for the newly trained AI observer seems to be a better representation of the sensitivity of real observer to noise. Now, summing up, what we can see is that the size, current existing data sets are too small in general, maybe to pretend that a network will learn from them and go beyond the prediction and try to mimic, right? But what we have seen with our few experiments is that maybe some of our prior knowledge as researcher can be encoded as constraints or assumption, and include this assumption in the training process by truth transfer learning, or again by putting some constraint on the optimization problem that guide the training process. So yeah, this was mainly what we published on that paper. But our ongoing research now is basically on trying to train this neural net, this AI observer, to take high image with high high resolution, including, you know, in particular, what we have been doing so far is that of taking the input image, resizing it to a small part, you know, 224 times 224, but this might have some effect. We are not even sure on the, we are certain, we are not sure 100% that it have a significant effect on the evaluation of quality, but we would like to directly feed a very high image to the network. We evaluate, and to this end, we have collected from professional photography website a certain number of top quality images, on which now we are focusing on the question of, well, what are the HRC to apply to these images, at which resolution to apply this HIC, and later which resolution this image should be shown to the subject during a subjective test, and also how to feed them to the neural network. Okay, because obviously large image come with several problems for the training point of view. To this end, we're investigating techniques as trying to use a bilinear linear layers that allow to take arbitrary size as input, as well as spatial pyramid pooling layers. Okay? I think this is all for this second presentation. Thank you for your attention, and looking forward for your questions and observations. Thank you.
Okay, thank you. Are there any questions here from the audience? Or from online? I don't see questions from the online audience. Questions from here? It seems not. So, thank you, Eric.
You're welcome, Enrico.
Thank you. We stay online.
Should I unshare my screen now? Is that okay?
Yeah.
Okay.
So, oh yeah, that was Patrick.
Then I have a quick question for you, Loic.
Yeah.
Why you don't consider content ambiguity in the model when you train the DNN? It could be also something of interest.
I mean, it's a great question, Patrick. But again, the problem in this simulation here, how can you think about the concept of my simulation? How can I a priori assign for a specific content and ambiguity? Like you want me just to assign it at random, because I don't, because maybe for the bias and it's okay that you decide, but the content ambiguity, shouldn't it be kind of content feature related? You see what I mean?
Yeah, no, I was just thinking of one version of surreal content, right? Where the content ambiguity is somehow also identified, and this could be used for something you want to learn about.
Okay, you can do this if you find a data set that is large enough with individual opinion score to directly compute. But in general, finding large scale data set with individual opinion score is a bit hard. But now that you say it, we will try to see if there is any.
Okay, I see. So it's a matter of missing data for the
yeah. So
but you can use eventually the metric as annotator also and the agreement between metrics to leverage some kind of content ambiguity across content, right?
Sorry, I did not. Will somebody repeat the question? It's kind of difficult to hear from.
So, you could use also the ambiguity between metrics.
Yeah, exactly. Yeah, thank you. That is also a very nice idea. Indeed, something that we work on MM. Yeah, we can use. Yeah, definitely. Thank you. I will test that. Thank you. Ambiguity between metrics. Yeah. Thank you. I took a note on it.
Any more questions? No? Okay, so I'll go with the next presentation. It's actually by me. Let me share the screen. Okay, so thank you. Well, actually, this will be quite short presentation and just a few updates on what we are doing actually in Track Hybrid, apart from what Luc already presented. But I introduced the Track Hybrid group before, but I mean, the Hybrid name comes from the fact that we, in the beginning, I mean, 10 years ago, maybe even more, it was meant to develop a no-reference hybrid perceptomistic model, but as you saw just now with Loic's presentation and the other presentation that will come, Basically, we are moving more towards, doing, addressing research questions which are hopefully interesting enough and have a long-term impact on the video quality research community. And so that's what we are going, what we are doing now. Actually, we are really strongly interested in researching about models that can somehow predict the behavior of single observers in subjective experiments. And the way we are doing it, that has already been presented by Loic, also in past VCOT meetings, is through these deep neural networks, which are basically what we call AI observers, or artificial intelligence-based observers. And what we are currently exploring now is this human-in-the-loop approach, because what we realized is that with these AI observers, you need, of course, to have large databases, subjectively annotated and so on, and we know how difficult it is to get them. And so we hope that starting from training networks of big data sets which have been objectively annotated in some way, even with prediction from other networks that try to predict subjective scores and so on, but we can start from something that which has been made by algorithms, and then refine these predictions through the use of a few subjective data that we collect by asking human observers, and in the beginning it's us from the group and then somebody else who can participate. Asking these people to annotate some peculiar images or videos which we deem very difficult for the networks. We hope that we are able to refine this network interactively. Okay, so every time we retrain or we do a partial retraining of the network, and we get something which hopefully works a bit better. And we see from the result of the network, which is the content that is more difficult for the network, we give it again to the subjects for an evaluation, for a subjective evaluation. We feed it back to the network and so on. And we hope to come out with some good results in this sense, without doing too many subjective experiments, basically. Because the point is that if we would like to model single observers, we need to ask in the same subject to repeat the experiments, which is of course difficult. So that's the whole idea. We are currently working on this, and we actually don't really know if the process will converge or not, but hopefully we hope to make it converge in some ways. As Loic said, we are working on creating a large data set of high-quality, high-resolution images. This was mainly the contribution by Glenn, who could not participate in this meeting. But actually, as Loic said, we basically have collected quite a large number of professional photographies, with high resolution and high quality. This is just a sample, but there are like 22,000 of them, which are at least full HD resolution or even more. And the point is that we would like to explore how to use these images when they are fed directly into the deep neural networks. Because, until today, there are very, very few works that try to use high-resolution images as the input of the neural network directly. As Loic said, but as you probably know, typically they use these 224 patches, which are quite low resolution. So if you have artifacts that can be seen only on high-resolution images like Full HD or something like this, we don't think that a network would extract such information to give a prediction of quality, especially in the high quality range. So that's why we are trying to go towards this approach, and we have some ideas, like some ideas as well, how to try to address the problem of this increase of basically of the dimension of the network, and especially the last layers of the network. And there's also a second method, which is the IGVQM that I talked about before. It's the Implementer's Guide to Video Quality Metrics that has been, let's say, discussed for, I would say, many years until now in VQuack. Basically, here the idea is to have to use a large set of subjectively annotated datasets. For this one, we have the subjective data, even though the collection and methodology was a bit different sometimes from one database to another. And here we would like to focus on computing all the objective quality values. I mean, the common ones at least, Pearson analysis, VMAP, and so on. And since we have the subjective data, we can try to provide, do the usual analysis and provide in the end standard guidelines to how to correctly use this video quality measure, because many times we have seen that people in the community uses metric in the context which is not really correct. Okay. And so at the moment we are focusing on using open source software, in particular libraries such as the libvmap, which provides quite a number of objective measures like the use of this analysis and so on, and the various versions. Actually, there are quite a number of them as well, because if you consider also the bootstrapping version and so on, I mean, we can also estimate something interesting like confidence intervals and so on. I have a few results about this. Actually, we would like to do all this work in a reproducible way as much as possible, because we aim to make everything public and repeatable as much as possible. Also, that's the point that we would like to address. We need a common format to represent the subjective results. Actually, I was thinking, we were thinking about using this real format, basically, let's say the input format for the well-known real software package. I've seen this morning, I didn't know, even I asked before that there's a SUJSON repository that aims basically to produce a common format that is useful in this sense. So we will for sure take a look at this. Okay. So the plan for the Implementer's Guide to Video Quality Metrics is to offer this standardized functions, methods, and so on, and particularly investigated something which is very often asked, like the temporal aggregation methods. We all typically do average over time. Arithmetic average, but there can be better ways of doing this, or maybe offering standardized logistic mappings to normalize the linear scale, especially for measures which are not supposed to be in linear with the quality, like this analysis and so on. And actually, we are working. As I said before, I'm going to find more people working on this activity, and because it's quite an effort, at least in the beginning, to make all the formats, make all the conversions, and make all the data available, to run these experiments in a systematic way. Just to give you a rough idea what we can come up with, this is one of the datasets in list. That's called the AGH and TIA Dolby. That has 200 DBSs and 70 measures objective scores from subjects. Okay, and you can compute a lot of information like statistics and so on. This is really the simple stuff like scatter plot between MOS and VMAP. But for instance, you can observe the difference that you can get when you use the algorithm that was proposed at the time by the Netflix guys with VMAP instead of the arithmetic. Okay, in this simple case, it was not that much difference. I mean, you can see something in the graph, but I mean, statistically speaking, there's not very much difference. So that's the kind of analysis that we would like to put for the class. Or like, as I said, if we are computing the VMAP banking, they call it, but it's basically a bootstrapping method where you will run like 22, I think, versions of VMAP, which are already included in the VMAP package. And so in this way, you can estimate a standard deviation together with the VMAP score, or like something that can be assumed to be like the 95% confidence interval value. And you see that, depending on the values of VMAP, but also on the type of sequences and so on, you get different scores. And having these scores already computed and available for further analysis would really improve, how we can spread this, better, good way of using these measures in the, well, of course, in the video quality research community, but also for people that needs guidelines and are not really expert, I would say like us, hopefully, in performing subjective experimental quality evaluations and analysis. Okay. So that's more or less all. I've run a call for participation. I think after last week meeting in December, just one of you answered. That was Ali from the University of Nantes. Thank you. And if there are any other people that would like to participate, just let me know. Let us know. So this is the last slide in Czech. We run bi-weekly conference calls. You are very welcome to join. Typically, they are bi-weekly on Monday, but we are flexible. We can accommodate different schedules. We are not that many at the moment. And next is next Monday, basically. Here you can find all the references. I think we will share all the slides. We will send to Margaret that she will put the slides online on the website. So if you're just curious, just put Big Web Jag into Google and you'll find our website. That actually we run more or less like the software tools and software methods tools. So it's a GitHub page is quite flexible for your data. So that's more or less all. In case you have questions or suggestions or feedback on what we are doing, you're mostly welcome to tell us. Any questions? Any questions or comments? Yeah.
Did you use VMAP 4K version or?
Yeah, actually, we are running all measures that are available with VMAP. So indeed, even if it's even if it's not 4K, we also run the 4K and so on, because any set up the system, you can run basically every measure if you like. And so we are curious also to compare what's the effect between using one model rather than another with VMAP, for instance, which should provide several models.
But imagine your image is 4K, but if you want to compute the 1080p, do you downscale it, or you just compute it at the original resolution?
Yeah, actually, at the moment, I think we didn't have 4K images in the data set, but that's an option that we should consider. How to run it, and indeed, this should be something that goes into the guidelines, because it's a very well-known. Frequently asked question, I would say, how to run the VMAP when your resolution does not align with the one of the model. It's not like Full HD or 4K.
I think it was offered to just use the closest resolution. So
yeah, that's an option. But maybe with this data sets, we should be able to give an answer of what's happening, or when you use the full HD instead of the 4K, and the resolution is not maybe neither one, neither the first nor the second one.
How could we aggregate this different objective data if their scaling is different from each other? Like one is from 1 to 5, one is 1 to 7 or something like that. Did you have this?
Well, actually, we worked only on two data sets until now, and at the moment they were all ACR 1 to 5. But that's one point. I mean, the fact is that I mean, we would like to provide a system where you can rerun some simulation or rerun some experiments or analysis easily, so that in case you have a doubt like this and you would like to explore something different, you can do that. Because the data, I mean, the subjective scores and the objective scores are already available in a machine ready format, so that you can just run the experiment and see what comes out. That's the most interesting part, let's say, for us, which are for experts in the quality evaluation. And for the others, let's say, we'll try to come up with some guidelines for some, some ways of, performing experiments in a way that is hopefully, let's say, mostly correct. Yes, please.
Just you mentioned this, the approach where you are training and the training scene, and that just reminds me. And continuous learning, lifelong learning, like a big topic in machine learning, and there's CVPR workshop on it almost every year. So it'd be good to check what's happening there, because actually, like incremental retraining of neural networks is not so trivial in that techniques.
Yeah, and we know it's not so trivial, but I mean the point is very very well appreciated. Thank you. We will definitely check what's going on there. Thank you. Any more questions? Check online. There are questions online. I mean, just speak up. Since not.
Do you have any data set which is annotated at different different screen sizes for the same content?
I need to check. I remember, I'm not sure. I don't think so, but I'll check it offline. That's I mean, the document is maybe I can put a link to the. It's
I will check the list that doesn't look. I don't know. Maybe I need to check as well.
Yeah.
The HD, the UHD from Ilmen now might be. I'm not sure.
Yeah, we will check. Okay.
They will be top of this. I think Wednesday.
Yeah.
We also had another site.
Okay. Yeah, yours is included. So yeah. So there is definitely there.
I mean, there are a few. I don't know if there are like in your.
Okay. But the data set is included.
Okay, good. Thanks. I'll check.
Okay. Thank you. Any other questions? No. This is not. It's Maria's turn for the last presentation in the session. Well, I leave the floor to you.
Let's kind of use the Zoom and then share it to the Zoom person. Okay.
We can all see it online and in presence. So this is a follow-up presentation on something that I presented in a previous meeting. I will summarize what I mentioned last time. So for those who did not attend the last time, there will be a short summary. So this is on the relationship between SSIM and mean-square error of PSNR. And in particular for DCT-based compressed images of video. So a quick reminder of what was discussed last time. So in order to assess the quality of lossy compressed images, there are a number of ways. So the more classical ways are to consider the mean-square error or the PSNR. These are in particular the most mathematically tractable ways to assess the quality and to treat the quality. Other possibilities are SSIM, for instance, which is a metric better representing the perceptual quality of images and video. And there are, of course, much more advanced metrics, DMAP was mentioned before, and many other metrics, which are, however, more complex and in many cases not mathematically tractable. So the goal of this presentation is to show how the SSIM can be related to the mean-square error and the PSNR, and to show some examples and some new results with respect to what I presented last time. So the assumption I will do in the rest of the presentation are these two assumptions. So first of all, the mean of an image before and after compression is the same. And the other assumptions, which is a bit stronger, I will show later, is that the variance of the image before and after compression is the same. So compression does not vary the mean and the variance of the image. How are these assumptions good in different cases? I'll show here just an example, there are more later. So this is the case of a classical image used for image compression, the baboon image that probably all of you know. On the left side, there is how mean varied with a JPEG compression value. So on the right here, you have the original image, quality 100. And as you go left, the quality of the image decreases. So you can see that in the case of the mean, the assumption is really valid because this is a zoom. So you can see the values here from 145.86 to 145.94. So it's really, this is very stable over the compression ratio or the quality. So for the variance, this is a bit different. You can see here, still this is zoomed. So this is quite constant, but if we zoom, as we have done here, we can see that as the quality decreases, the variance tends to decrease. But for quality ranges high enough, for instance, for JPEG compression factor above 70, the assumption can be considered valid. And I will show later some other examples. And actually, what we're interested in is in the cases of qualities above a certain value. So when we do video streaming, where we arrange the quality vectors for video streaming, we don't care about quality, which is, let's say, 20 of PSNR, because this is too bad in any case to be delivered. So we are interested in quality ranges above a certain value. So this assumption is globally valid. I will show later more detailed results so you can see how this assumption affects the results. This is just another example on the local variance. This is again the same example image, so the baboon image. Again, JPEG quality factor horizontal axis, so perfect quality uncompressed here, higher compression as we go left. So you can see that this is quite stable. So this is for the first 5 blocks. Each of these curves represent one block. And you can see that the variance is relatively stable as the quality varies over time. I presented this last time. There is a lot of mathematics. I will not go through the details of it again, but just to summarize, so what I had shown last time is that from the expression of the SSIM, which is on the top, which depends on 5 main elements. So the mean of the original image, the mean of the compressed image, the variance of the original image, the variance of the compressed image, and the covariance. We can obtain a simplified expression with these 2 assumptions, which is the one here, top right, circle in red. We also can observe that if we only do one of these assumptions, so if we only do the assumptions on the mean, but not the assumption on the variance, we have, I can use the pointer for those online. In this case, we have this version here. If we do only the assumption on the mean, and I will show later on that this is extremely accurate even for very high levels of compression, but not applied, cannot be applied in all cases because we need information on the variance on both the original and the compressed. As I have shown last time, for the calculation of the global SSIM, we need to do the pooling over the blocks, and then hence we need to do the same with the PSNR or the mean square error. I haven't gone through many details since I presented these in detail last time. If you wish to have further information, you can check the paper from NSP 2023 in October. Okay, from now on, I will provide some other examples, use cases, and some new results. So what are the possible use cases? The first one is not very frequent as use case, but still can be used in some cases. So the first case on the top here, that you can see here, needs both the variance of the original image and the variance of the compressed image. As I mentioned, very accurate approximation, applicability, all in some use cases when we have both these elements. What are more interesting are what are here 2 and 3. So in the second expression, I consider here, since I assume equality, I consider here the variance of the compressed image. So when I know only the variance of the compressed image, for instance, in reduced reference scenarios, I can use this expression here. For instance, I can assume that I know the mean square error because it is in metadata delivered. Or the third case, when I consider here the variance of the original image, can be considered in the phases of rate distortion optimization for compression, for instance. So each of these expressions have different use cases. Prior work, partially discussed last time, somewhat details here. So there was a work from Dosselman 2011 that you can see on the top that recognized the relationship between SSIM and the mean square error. You can see the expression here, where all the terms are detailed in the second part. And Dosselman really recognized that not all these terms have the same importance. So somehow he opened the doors for some possible simplifications. Also not mentioned here, I had a chat with Amy Reitman at the conference, and she told me that in 2007, they already recognized the possibility to relate the two metrics and to possibly simplify the expression, but they did not take it further. At the bottom here, you can see 2 other interesting works from Hore and Zhu from 2010-2013. You can see here what can be seen as a summary of their observations. So they focus in particular on intermediate qualities. And they mention that the relationship between PSNR and SSIM, when parameterized with the variance, each of these curves is associated to one value variance, can be considered linear. The only problem is that we are interested mainly in relatively high values of quality. So we are interested in here, in this part here, for SSIM above 0.8. So when we consider here quality versus rate, playing with the curves that we consider for the organization of the letters, typically we're interested in quality values above a certain value, because as I mentioned before, transmitting a quality which is too bad, sometimes it's better not transmitting anything. Okay, another interesting work that I've been found very recently, so I didn't mention it last time, is this work from Tan, Geo, and others. So very interestingly, they also find a relationship of SSIM and mean square error, including the variance as a parameter. That's very interesting, but that's a different expression, if you can see here, because this was done under different assumptions. So in that case, the assumption they did was, in the case of additive error, with zero mean and error uncorrelated with the signal. And they derived this expression here. I reported below here the expressions that I presented last time, that you can see here at the bottom. So you can easily see the differences. In particular, if you focus on this term, MSE over 2 sigma x to the power 2 plus 2, in the two cases, you can see that in the first case, this is assumed equal to 1 over the SSIM minus 1. While in the case here, this is assumed equal to 1 minus SSIM. So to give an intuitive idea of the relationship between the two, what I reported in the plot here is how this term, mean square error over 2 sigma to the power 2 plus C2, was considered in the two cases. So the blue curve is with the approximation that I considered, represented last time. And the red curve is with the approximation provided by the other colleagues in that work. And we will see later on that the approximation that I consider is provides a tighter approximation of the actual value of the SSIM in the case of DCT compressed images, which is the case of interest here. Okay, some results here. So first, some results of the approximation I provided, and then I will show some comparisons with what I called benchmark here. So I consider 6 different images, which are classical images in the community, and calculated the MSSIM with the MATLAB implementation. And the MSSIM is estimated in 3 different ways. Let me check, I think I reported that later. Calculated in 3 different ways. In one case, considering the variance of the compressed image. In one case, considering the variance of the original image. And in one case, with no assumption on the variance, but only assumptions on the means. So only assuming that the mean of the original and compressed image. So let's focus first on the MATLAB implementation, which is not visible, but this is really overlapped with this purple curve. So this is really overlapped with the case of no assumption of the variance, where we only do the assumption of the mean. And this is this curve here. Then you can see that if we consider the variance of the original image, we overestimate the MSSIM. If you consider the variance of the compressed image, we slightly underestimate the SSIM. And this is the same for other images. So you can see here for the Lena image, I'm not reporting the image. We all know that we cannot do it now. I don't know if you know, but with Autopilot, we cannot report the image anymore. So with Barbara, the approximation is impressive. You can see with all the methods, the approximation is really impressive. The curves are overlapped. So this is for the Peppers image. And again, slight overestimation with the variance of the original image, slight underestimation with the variance of the compressed image. And this is for both here and both. Now let's focus on the comparison with what are called the benchmarks, since this is the other expression which has some similarity with this one. So again, here, the MATLAB implementation is the one with circles. So you can see this here. Now, in these results with the benchmark, since the benchmark only considered the variance of the original image, I only consider the version of the approximation I provided with the variance of the original image, because of course it's not fair to compare with the other one. So again, the green one is with the approximation I provided, and the blue one is with the approximation in the benchmark. So you can see that the green curve is nearer to the one with the circles, which is the MATLAB implementation. And the same here for other contents. So this is for vectors. So you can see here as a reminder the different expressions considered here in the curves. And here for other contents, Dana, Goldhill. So you can see, for instance, again here, the green is the approximation that I provided last time. The one with the circle is the MATLAB implementation. And the top curve is the other approximation. And here again, the one with the plus is the other approximation. Here, the approximation that I used, actually the curves are indistinguishable with the MATLAB implementation. And similar here for cohort, where the other one is clearly visible. Okay, it was a short presentation since I presented the main concepts last time. So the main goal was to obtain a simple relationship between SSIM and PSNR, or mean square error, that can be used in a number of scenarios where we need, for instance, mathematical tractability. So being able to have mean square error greater than SSIM in the expression simplifies, of course, calculation for a distortion optimization, but can also be useful at the receiver side with reduced reference quality assessment. There is dependence only on the mean square error and on another factor, which can be considered a content factor, which is the variance of the image. We have seen that the assumptions are reasonably good for the quality range of typical interest. In particular, you have seen in all these curves here that for very high qualities, all the curves are really overlapped. And as the quality decreases, the curves tend to diverge because of the approximation of the variance in the case I provided, and because of their approximations in the other case. Okay, I think we can stop here. So for further information, in particular on the first part, you can refer to this paper.
Okay, thank you. Are there any questions?
Right. Thank you for your presentation. My question is about the assumption. As you know, nowadays the use of post-processing tasks like super resolution image enhancement is increasing. I'm curious to know that if they have an impact on the assumption, after DCT operation, we apply some post-processing methods.
We should check if the assumptions are still valid. I'm not sure. It depends on the type of post-processing that you apply. If it is a type of post-processing that keeps the mean and the variance, I expect the approximation will hold. It really depends on the type of post-processing that you apply.
So, for example, like filters for blocking, deblocking filters and these things. So,
I haven't tested it honestly, so I prefer not to answer without testing. So, but this can be further tests that can be done in the future, of course.
Just like
check how much we can push it beyond just the DCT compression.
Thank you very much. That's quite interesting. I'm wondering if you have tested with larger data sets to see the content dependency, because I assume that if you compress more for more complex images, you may have larger deviation from the.
Yeah, you can see, for instance, here, so these images have varied complexity. So if we go back here, for instance, you can see that the baboon images, I would consider it a complex image, because if you have in mind the image, the texture of the fur of the animal is quite detailed. So I would consider this very complex. So you can see that the deviation is higher indeed. So this is a good observation. While for much easier images, for instance, also Lena is not the complex one, but also Barbara, for instance. I would say in terms of texture, I would consider it a not complex image. You can see that the deviation is lower. So you
Because
can
the
see,
more we compress, so we usually lose the high frequency data and we reduce the variation, right? So
yeah,
this is what I expect. Thank you.
yeah, exactly. That is exactly good observation.
And did you also, the reason for this study is to make it less complex, the computational SSIM and
Yeah, when you want to do a social optimization and you want to optimize mathematically, then less complexity is the
do you
better.
know how much have you tested? That it's almost
Sorry?
faster than the original.
No, I haven't tested it, no.
Any more questions? Check. If no, no more questions, right? No, thank you. Oh, well, Patrick.
Yeah, but it was on one slide, because when you showed the difference between the one of the SSIM formula, you restrict this comparison to a certain scale. I was wondering
Yes,
why
yes.
you study this.
Yeah, as I mentioned, we are interested in quality values above a certain value. We are not into whether quality is too bad.
Yeah, but on the other hand, when you look at the rest of the presentation, you cover almost all the quality values.
I wanted to show it now. I've shown all the quality just for the approximation of the variance and the mean, not for the results, because we are not really interested in it, but for the assumption, I wanted to show that as the quality goes down, the approximation is less valid. So that's why I consider larger range in the first part. But in the second part, I thought it was not really relevant because we, as we said, we don't really want to transmit the necessary gap below 0.8. This is not.
But do you think to do some kind of a direct comparison, so you could compare the result doing the different optimization with respect to the different hypotheses, and present the result in terms of direct.
The results can be presented in another.
Using PSNR. If you suppose you do the optimization, whatever formulation.
Yeah, but I'm not sure what is your point, because originally you mentioned the range, right? That you
This is another question that I'm asking now. So
Okay,
I'm not sure.
I was going to find
Yes, you-
the
Okay, sorry. That's always not always easy to follow. Well, first of all, I'm glad you put the paper that I suggested to you after the discussion with Amy and you study all these things. But I was thinking that if you want to somehow.
Yeah, you suggest with any the work from.
Yeah, so what?
Work from the
first
reference
paper, but then
presentation.
there was also the other paper that you have already.
This one here,
Yeah,
you didn't mention any, but I discussed with you as well.
Yeah, we don't have the slide. That's not true.
You're
Not
not
sure.
doing anymore, but yeah, it was the one.
Dosselman and,
One of the works in the from Dosselman, yeah.
Discussion at the
Yeah.
So I was thinking that, so now I switch to the second question. Why not providing the result in terms of, you can do an optimization of compression using any of the models that we propose and show the result in terms of BD rate using
Yeah, why
PSNR.
not? Why not?
So yes, why not?
No, why not? This can be a future work.
I'm
Why not
saying
in the
I
sense that
just
this
want
could
to
be.
find out why.
Because
I
there
think-
is a-
Because this is the thing that.
Because my main interest here was not to compare, for instance, different projects or something like that here. This could be a future work. But the main goal here was to show the validity of the
I
assumption.
got
and
it, I
how-
got it.
Yeah.
My suggestion
No,
is
that's
to do
good.
it, to do it, but there's a good reason for that.
Yeah, yeah.
It's because if you look at the codec, development discussion standard, and I will quote here because you are dealing mostly with image, the JPEG activities. This is the type of result they
Yeah,
gonna
definitely,
look at.
this can be
So
a-
they need that. Right?
an interesting,
And this can eventually push a little bit more the effort towards better quality metrics, better way to evaluate the codec performance.
Yeah, this can be an interesting follow-up,
So
and actually,
if you want to reach out as the codec development community, at one point of time, we should speak a little bit
yeah, this
their
can be,
language.
yeah, this can be definitely interesting. You probably know that we are working on video rate as well, and we have
Yeah, yeah.
also a new paper, hopefully, that will be published in an extension of our previous one. So this is in our interest as well to relate this one with the work we are doing on the video rate. So that's a good suggestion for follow-up.
Okay, thank you. Any more questions? No? So, thank you for attending the JGAG session, and so, I think the chair could say something.
Yeah, I think we kind of reached the lunch time. Did you, did you have something you wanted to announce before?
Just because we need to come back very fast, so I suggest to go to one restaurant very close to the university. In Pizzeria. Also in front of the university canteen, is also one option. But my second question is for dinner, so we want to reserve a restaurant, so if you want to join after the match around 8 p.m. I need to know the number.
And how do we communicate that to you?
In the WhatsApp group, I will share the direct service.
Okay, and do you want us to respond to the WhatsApp?
Now, if I